Okay, so this mini lecture is kind of getting into a little more detail about programming in the Arduino environment. So you've done some programs, mostly just code we kind of fed to you or that you might have found online, but really understand what's going on. You really need to be able to code pretty much from scratch. And to do that, you have to understand some of the subtleties that aren't really obvious at all when you get started. So first and foremost, this page here that you see is the Arduino language reference page. Bookmark it, memorize it, get access to it, make sure you can get to it easily. So what you have here is on this main page, the language functions. So these are all the calls. You've seen some of these, right? Digital write, analog read, analog write, right? We've seen both of those, particularly some common mathematics functions, the trigonometry. These are dealing with characters. And down here, we talk about different variable types, conversion of types, and things like loop and setup, and how we control the flow of the program. So you've had a course in C++, you had a course in MATLAB, and what you'll probably find, at least what I have found, is that programming in the Arduino is kind of a combination. It has a lot in common with C++. In fact, it really is based on C, which was the predecessor of C++. And so is MATLAB. So you'll see some commonality in MATLAB, but unlike MATLAB, this language, like the C language, is what we call strongly typed. And that means you have to declare every variable you use in advance, and you have to tell the computer what type of variable it is. And by that I mean, is it an integer? Is it a floating point number? Is it a character? Those are the main ones we'll be using. Because when you declare a variable, you associate that variable name with a storage location in memory in the Arduino, in the RAM of the Arduino. And an integer takes less space than a floating point number. So it has to know how much space to allocate for it. And that's essentially what happens. The Arduino environment is very unforgiving about this and doesn't always tell you when you've made a mistake. And where this will show up is when you do mixed type mathematics. If you multiply an integer times a floating point or something like that, the results will not be what you expect by and large, unless you're very, very careful. And that's really what we have to talk about today. Okay, so let's also go over to the programming environment itself. So here is a typical Arduino sketch, right? This is how it starts. It sets up these two functions, and this is how you set up a function, right? Void setup, and then all the statements that are executed when setup is called are between the two curly braces, and then loop also between two curly braces. This first character here is a variable type declarer. In other words, functions can return a value when you call them. You can say some variable name equals setup, right? But when we say this, we're saying that setup doesn't return anything. That's what the void indicates. But if it were to set up an integer, you'd put an int there. Okay, so there's 3 locations in the sketch, right? We've already seen the loop and setup, but there's this other place up here above it, okay? And this is where we put things that are common to setup and sketch, or I mean setup and loop and anything else we do in here. To understand that, we should talk a little bit about scope. Okay, so I already mentioned that setup and loop are functions that are called by something in the background, right? Arduino's got some firmware that you don't get to see, but that firmware is every time you reset it or power it up, it goes through some initialization, zeroes out a bunch of stuff, sets all the outputs and inputs at known states, executes the setup function, and then executes the loop function repeatedly. So it sits in a loop calling loop, right? And that's all it does. It never stops. Okay, there's no stop command in the Arduino. It just keeps going. Variables declared and used within the function are only available within that function, within that execution of the function. Okay, so the variables don't persist. And if you declare a variable and use it in setup, it's not available in loop. Loop won't be able to see it. If you declare it within loop and use it within loop, it'll work fine, but the next time you go through loop, the next time loop is called, it won't be persistent. Whatever value it was is gone, and it gets reset. Okay, so if you want to have memory of something from one loop execution to the next, or from startup to loop, setup to loop, you have to declare the variables up here, and then that declares them as global variables. So they've got global scope, not just scope within the setup. So we'll see that in lab 2, and we'll and in fact, whenever we declare things like our pin numbers and things like that, we usually put it up in that chunk up there. So let's see how that works in a very simple program, and this is the one that starts it. So when you learn to program in C++, or maybe even MATLAB, or any language, typically somebody teaching it will start with what they call the Hello World program, where you just write the simplest program that prints to the screen or to some output Hello World. The version of that in mechatronics is the blink program, turn an LED on and off. So so let's do that. Let's follow that through. You've seen it before, but let's do it again. So what I want to do is I want to pick a pin and hook up an LED and a resistor to it. Let's say that's pin 10. Okay, and in the program I need to tell the I want to establish pin 10. I'll call a variable called myPin that I'll associate with 10, so that if I want to change it, I can just change it at one spot in the program. I need to establish it as an output pin, because I'll be writing to it, and then I have to loop through turning it on and off, right? So I'll start up here at the very top of the sketch, and this is where I will declare an int, call it myPin, like that. Okay, and then so I'm going to show 2 different ways to make this work, right? So down in here I can say in my setup, I only have to do it one, myPin equals 10, and then I want to set the mode to be output. So that function, if you remember from the language reference. Okay. Notice that when I typed pin mode, when I was finished with it, it changed color, meaning, oh yeah, I recognize that as a function. And you'd find that function back here in the language reference. I'll go back to here. So here's our language reference page, the base page. There's our pin mode. If I go in that, I bring that up. I say, okay, this is the call. Give it a pin number and a mode number, or in the mode type. And the mode, these are the 3 choices for the mode type: input, output, and input pull up. A quick aside, these language elements where they're in all caps, these are predefined constants, so they're known to the compiler. These are probably just integer values 0, 1, and 2 or something like that. But you don't have to look under the hood. You don't have to get that far into it, as long as you just remember those are those are the 3 keywords. So that makes it a little easier. So going back to here, I can then so this will execute once. It'll associate my pin, set the pin mode. And since I declared my pin up here, it's going to be available in both functions. So now I go into here and I say digital write. See, it changed color, so I spelled it right. And I want to send my pin hi. And that changed color too. So when I type those all caps, those are keywords that the compiler recognizes. I'll delay a second. And of course the delay function delays by that many milliseconds. So 1,000 milliseconds is 1 second. So it'll go on for a second, go off for 2 seconds, and then go over again. So let's take a look at this. I can I don't have it hooked up to an Arduino right now, so but I can at least compile and make sure it's okay. First thing it asks me to do is, hey, why don't you save that? So I will. And now it's compiling the sketch. So I compiled the sketch, and you can see that I got no error functions, no error signs. Everything looks fine, not using very much of my memory, and it's all good. Okay, so this would work. But notice that my pin is declared once, we never change it again. So you can take care of that if you have functions like that, or I'm sorry, variables like that. You can handle that in the declaration by putting what we call a type modifier on. And in this case, it's constant, okay, or const. And at that point, say, okay, I'm now setting it equal to 10 there, and I can get rid of this line in the setup. So this is the other way to do it, and it's probably the preferable way. So if I go to compile that now, it shouldn't have any trouble, and in fact it doesn't. So that's probably a better way to do it. So that's a simple program. We have these declarations that go up here for global variables. We have the setup that executes once, and we have the loop that executes repeatedly. So that's it. Hopefully you've kind of figured out most of that already, but maybe this will clarify a few of the finer points. So thank you.